in this example, we've got the product of x squared times e to the x. So whenever we've got the product of two terms inside an integral, we're going to try integration by parts as one of our methods. So to use the formula, we need to work out what is u going to be equal to and what is v going to be equal to. And we also need to know what's du by dx and what's dv by dx. So to use integration by parts, we're going to try and make the integral that we're trying to find be equal to the left-hand side of the integration by parts formula. So our options are, we could have u is x squared and dv by dx is e to the x, or we could have u is e to the x, and in that case we'd have dv by dx is x squared. So if we're using the acronym LATE to try and help us work this out, we've got one term which is x squared, which is what we call algebra in LATE, power of x, and we've got e to the x, which is an exponent. So remember, whichever letter comes first in LATE is what u is going to be equal to. So a comes before e in LATE, so our algebra term is going to be u. So we know that u is going to be x squared, and that means dv by dx must be e to the x. If you're not using the acronym LATE, then you can actually see that if we had u was equal to e to the x, then when we differentiate it, we're going to get e to the x, which isn't going to become any simpler. And when we integrate x squared, it's going to get more complicated as well. So if we did get it the wrong way around, then we would end up with an integral that's no simpler. So next, let's work out what du by dx is. So that's 2x if we differentiate x squared. And in order to find v, we need to integrate dv by dx. So the integral of e to the x is just e to the x. So let's use the formula then. So on the left-hand side, we're going to have the integral of u dv by dx, which is x squared e to the x, and that's the integral that we're trying to find. That's why we made sure that these two was x squared e to the x, and then equals uv, so x squared e to the x, minus the integral of v du by dx, so that's 2x e to the x. Okay, so with this method, we need to make sure at this point that we can integrate this term here, because if we can't, then we've probably got u and dv by dx the wrong way around. So we've got to look at this integral and decide whether we can integrate it. Well, we can integrate it. We've got the product of one term multiplied by another term. So that means that we're probably going to use integration by parts to work this out, because no substitution is going to work. So in this example, we're going to have to do integration by parts twice. So as a bit of a side note, we're going to try and find this integral. So find the integral of 2x e to the x dx. So we're going to use by parts. So we're using this formula from the formula book. And in order to use this formula, we need to work out what's u going to be and what's v going to be. And we also need to know du by dx and dv by dx. So again, we've got, if we use LATE, in this integral, we've got 2x, I'm going to treat it as 2x times by e to the x. So one term is 2x and the other term is e to the x. So in this integral, we've got algebra, which is 2x, and we've got an exponent e to the x. So because algebra comes before exponentials, the algebra term is going to be what u is equal to. So u is equal to 2x. And that means dv by dx must be equal to e to the x. And again, if you don't use LATE, then you could experiment and you could flip them around and see which one makes the integral on the right hand side possible. But because 2x is going to just differentiate to 2, that's going to make it simpler. and we always choose u to be the term that when we differentiate it, it gets simpler. So du by dx is equal to 2, and v is going to be e to the x. So if we use this formula on this integral here, the left-hand side of the formula is going to be the integral of 2x e to the x, which is what we're trying to find, is u times v, so 2x e to the x, minus the integral of v du by dx, so 2 e to the x. And we can work out what this integral is now. This integral, we can just use standard results. The integral of this is just going to be 2 e to the x, because e to the x integrates to e to the x, and then plus c. So our final step is to substitute this in for this integral here, because we found out that that integral is equal to that expression there. So the answer to this example is going to be x squared e to the x, and then minus, and then I normally put minus and then a bracket just so I don't make a mistake with that minus, and we found out that that integral is 2x e to the x minus 2 e to the x, and then you could put the plus c on the inside of this bracket, but you could just put a plus c at the end, which is what I'd recommend you do. So don't worry about the plus c when you do this integral. You can just put a plus c at the end of your answer. And then we can simplify this a little bit by expanding out the bracket. And that would be fine as an answer, or you could take e to the x out as a factor, and you could write it like this if you wanted to.